Hi everyone, welcome back to the shop. A really fun, interesting project to do today. I got a phone call from my friend Alec Steele and Will Stelter saying that they have broken their sword breaker project that they've been working on for 3 weeks. Alex said, hey, if I send you a Damascus billet, could you cut it on the water jet because it has a really interesting shape and design and get us back on track? I said, absolutely. It's supposed to be showing up here any second now. He also sent me a file on the computer to which we can redraw it, the blade that they're working on, and get it into a form to where the water jet can cut it. So we're gonna have to take a look at that and see what we gotta do there. So there's a sense of urgency to get this done, and we need to send it back to him as soon as possible. So let's go see what we gotta do. Here's what we got, guys. Here's Alec's billet. It's made out of a layered patterned Damascus. He's already hardened it and heat treated it, but the water jet's gonna keep the billet cool, but also cut it like butter. The billet actually measures 17 inches and a quarter. The knife itself measures like 17 inches and 1/16. And the width is 2 inches on the billet, and we have 1 7/8 of the actual knife body that we have to fit in here. So I don't have a lot of room to wiggle or mess up on this thing. This is kind of important that we measure how thick the billet is. And so we're getting about 270 there. 265 thousandths is kind of where we're at in the middle, 270. So I'm gonna use that information and plug that thickness into the computer. Okay, so here's Alec's knife in a JPEG picture form. I want to show you guys this. You see how this image is really like sketchy? Well, the resolution on the water jet is really high, and it's actually gonna try to cut all these little segmented lines, believe it or not. And then when I go to turn it into a 3D model, these are all part of the model. So can you imagine, these are all little segmented lines here that we got to deal with. So it's not a very clean image. So now we need to just trace this outline sketch and turn it into a DXF file. And the DXF file is the language of all these CNC machines, and that's how they basically generate a cut path. So there's some other ways to try to clean it up and smooth it, but you just lose detail and accuracy. So the best way that I found to do this is to just redrawing it and having a good entity to work with. It only takes about 20 minutes to redraw this, but it's well worth it in the end. Okay, now that we have all the lines drawn, now we have a 3D model of the knife breaker, and we can generate a cut path into the flow software and cut this out. What we're going to do is we're going to take the water jet and we're going to turn it over on its side, and then we're going to turn it back this way and cut it. So if it's not flat, you're going to get a bevel that's kind of weird because you're trying to follow a curve. So we're going to have to fixture this down to the water jet table flat. I have to give myself some sort of reference line for square, and I have an X and Y coordinate right about here at the end of the handle. So I need to give myself that same X and Y when I put it on this piece of board. So then I'm going to be aligning the board edge with the X and Y in the machine. Something like that. So I know the edge is running parallel. So I'm going to position the nozzle right there at that coordinate system, and that's going to be 0, 0. I'm just going to use these drywall screws, and I'm going to use the head to wedge it down to the piece of plywood. I gotta be real careful not to push the part over and put some twist in it with the heads, because once this gets cut off, all that pressure is going to get relieved, and then it's going to go to its natural position, and then the rest of the cut will be all weird. All right, to the water jet. the moment of truth. Let's pull this off the plate and see what we got. Hopefully I didn't destroy it, but I think Alec would be okay with whatever we deliver to him. So let's see what we got. Let's just say there's, wow, look at that. Look at the wood on that, guys. That's pretty cool. Sword breaker, I'll have to mount that on the wall. Man, look at it. There was nothing. Look how much room I had left, guys. Look to the edge on both. Wow, check that out. I had literally cut to the outside edges of that. I was, man, that's just insane. Look at, not a lot of room, wiggle room. I tabbed it right here on the back so that this part would stay connected so that I could have a little bit of rigidity, but we're gonna just try to pop this off. Bink, just like that. Bink. I'm a little disappointed. I didn't get my height set right and for the bevel. It'll be okay. He's gonna have to grind a lot of it back, but what I do wanna try to do is turn the knife on edge like this and cut down the edge of the blade with the water jet. But I'm not gonna do it on this knife. We'll cut a stand-in and pretend. This one's too valuable to tinker with, so let's get this shipped off to Alec. The problem is, how do we hold this knife blank in a position to where the water jet can access this edge and cut it? And I want to hold it in this like sacrificial drill press vise that I just used to cut random things on the machine. If you look at the way the knife blank was drawn in CAD, there's an imaginary center line that goes from tip to the center of the tang here. So I think I'm going to hold it in the drill press vise something like that. And then what I'm going to do is I'm going to find the center of the tang and the center of the tip using this height gauge over here, and then we'll clamp it securely, and hopefully that's enough to keep it from moving around. And then we'll run an indicator down the side to get the twist out of it. Just get it plus or minus 5/1000ths or so. That should be good enough just for a bulk removal of the bevel or chamfer. Okay, calling that good. This should be fun. I still think the grinder would still be faster, but hey, we're learning here. So let's give it a shot. Okay, we'll set our Z with our 1/1000th shim. Just go down slow, get close. That feels about it. And I've set the nozzle right to the edge of the knife, which is gonna be 0, 0. This dimension isn't really too critical, so we're just gonna get ready to cut it now. Check out how powerful that is. It's cutting through whatever that is, a 3/4 of an inch there, then 2-inch gap or so, then right through the body of the vise. Kind of funny. I'm gonna cut these off. I didn't want them to come off by themselves because I just didn't want them flopping around, so I'll just cut these fins off and then we'll have a look at it. Pretty powerful. I had the machine going pretty slow, and it took about 9 minutes to cut both sides. I think if I would have had it fixtured a little bit better and there was less vibration, I definitely could have sped the machine up faster and shaved a couple of minutes off there. I think it's what, 72 degrees. It's razor sharp. It probably could cut something. Ah! No. The reason why I didn't make a cut path that went all the way down and around the edge of the tip, if this was the water jet, it wants to cut at this angle, and it can only cut at like a 60, so it would have stopped right about there anyway. But if we would have designed the knife to where the tip stopped at a 60-degree angle. Heck yeah, we could have totally cut this all the way down and around and finished the tip off, which would have been pretty neat. But I mean, yeah, I think a belt grinder would definitely still be faster, but this is just a fun, cool little experiment just to see if it would do it. If you had a whole bunch of these knives to do, heck yeah, I'd build a fixture for it. For a one-off part piece, I think the grinder's still the way to go. Pretty fun experiment. Thank you guys for joining me. This was fun to be able to help Will and Alec out with the sword breaker project. If you'd like more information on the water jet and how it works, we have a video on all the little ins and outs and details and what its capabilities are and why it does what it does. So go check that video out if you're interested. But thank you for watching, and I'll see you on the next one.